Okay, so this is the fifth short video clip to accompany preparation for your assessed coursework, and it concerns the use of a particular notation to make it very clear how the operation of a computer takes place. So in topic 2 it was stated that instructions are simply bit sequences, for example 8 bits long. And in the architecture, we considered the first 3 bits represent the opcode, for example, add or subtract and move data from one location to another. And the next few bits represent a memory address where data can be found. And the instructions that we looked at were those involving these opcodes, and of course they'd be typically translated into binary. And so 000, for example, means halt the computer. 010 means store the contents of the accumulator in memory, save it in other words, and so on and so on. So the full halt instruction would look like this: 000, then an empty address: 00010. I suppose it should be 0101111. Simply means store the accumulator, store the value of the accumulator, whatever's held in the accumulator, in memory at location 1111, and so on. I just want to give you an illustration of a very simple sample instruction. So 0101110 can be split up into the first 3 bits, which represent an opcode, and the final 5 bits, in this case, represents the location of where data is to be found. Because if you recall, most of the opcodes involve doing things with memory operations, like putting something in memory or taking something from memory and putting it into the accumulator. So this is the architecture that we're working with. That's the data register, that's the address register, and as we've already seen, this is the CPU block consisting of an ALU and an accumulator, and this dotted rectangle represents the CL, the controller, which consists of a program counter, instruction register, and the actual controller itself. So let's have a look at the execution of an instruction in depth. So move data at a particular address into the accumulator register ACCC. At some point, this instruction was fetched from memory and was placed in the memory data register. And the opcode part of that instruction is moved into the instruction register, and the address part of the instruction, i.e. where the data is stored, will be routed into the memory address register so that the data needed by the instruction is made available again by being present eventually in the data register. So supposing an instruction fetched is in the data register. So here we've got the data register and we've got an instruction. Well, what's going to happen is that the opcode is going to be transferred into the instruction register. So there's a virtual routing operation taking place by means of the blue dotted line. And the actual data that's just been fetched from the main memory, this is the main memory, is going to be placed in the accumulator. And the address register is going to be filled with the address of the data to be fetched. So here it goes, and the control circuit is going to take this memory and do a memory read by just simply sending a read signal to the main memory, and out comes the data and put there. Um, and that's what I mean by saying that the data is actually going to be then routed into the accumulator. So the instructions, I'm sorry if I've confused you a little bit, the instructions are clearly, the steps of fetching and so on are clearly laid out and labelled by means of colour here. Um, okay, so study these steps very carefully, and a little section I've got here on the fetch, decode, execute cycle. The general mechanism behind the execution of such an instruction is that the computer will need to fetch the first instruction from memory. So we can assume, for the sake of simplicity, that memory has just 8 locations. The program counter register will contain the 3-bit address of this first instruction, and this address is put on the address bus, and the instruction found there will be read into the data register. And the opcode part of the instruction will be stored in the instruction register and decoded. And in other words, intuitively, it's going to be interpreted. And the memory address part of the instruction will be placed in the memory address register, and the data fetched from that address will be put into the memory data register. And under the control of the controller, it will then be routed on the data bus from the MDR to the ALU, and the operation will then be performed. And to make what happens even clearer, we use the symbol less than, or I guess it's just the less than sign and hyphen to indicate the movement of the data address. So this symbol here, these symbols here simply indicate that the data in register B, or memory location B, is going to be moved into A. And more specifically, we can write the name of a register and the source of an address contains, it's going to be probably data found at this address in main memory. So I can write the address of main memory is going to be moved or transported into the MDR. So that's a nice way of just writing that. So step 1, the contents of the program counter are going to be moved into the memory address register. Step 2, so we're going to get the first instruction out of main memory by doing this, by moving what's in the program counter into the MAR. Step 2, the contents of memory at this address, the address contained in the MAR, is going to be moved into the memory data register. So I'm being consistent with what I've described already. In step 3, the opcode part of what's now in the memory data register is going to be moved into the instruction register, and the value of PC is going to be incremented. It did contain an address. The address is now going to be incremented to represent the next instruction, and the instruction, the opcode, in other words, is going to be decoded by means of the CNTL unit, and we can, for the sake of argument, assume it's the add operation. So the fourth step is that the address part of the memory data register is going to be put into the main memory's address register, and the control will actually then do a read on that address, and what's going to happen is that the addressed location of memory is going to be moved into the data register. And step 6 is that since we've got an addition we're talking about an addition operation, what the contents of the accumulator is going to be added to the number now found in the memory data register, and the result is going to be placed into the accumulator. And step 7, well, you just repeat the whole cycle. You execute the next instruction. And at that point, I'm going to finish. And I leave you for future reference what I call a flow diagram indicating this sequence of operations. So thanks for listening.